All right, here we go. So today is Thursday, the 27th. Our two lessons that we learned this week are both on our opener. The first one is prime factorization, and then the second part is going to be square roots, which is what we talked about yesterday. So the first set of directions say factor each of the following. You're going to write your answers in standard form and then exponential form. So when I have the number 80, what two factors or what two numbers can you multiply together to get 80? 8 and 10. Do you have to use just 8 and 10? No, you can use 2 and 40, you can use 4 and 20. There are different variations that you can use. So if you chose not to use 8 and 10, that's okay. Danielle, can you factor the number 8?
Yeah.
What are the two factors of 8?
2 and 5. Wait, yeah.
How about 2 and 4? Okay. Now, what kind of number is 2? So I'm going to circle it. What kind of number is 4? Is it a prime number?
No.
No, it's a composite number, so I have to continue to factor it. So what times what equals 4?
2.
And you already told me 2 was prime, so I'm going to circle it. Okay, I come up to my 10. Kira, can I factor 10?
Yes.
Yeah, what times what? 2 and 5. Now we already know that 2 is prime. What about 5? Is 5 prime or composite? Prime, so I'm going to circle it. Once I am done finding all my prime numbers, I'm done factoring, I'm going to come up and write the numbers that I circled in standard form, which means I'm basically going to write all the numbers that I circled in order from least to greatest. So Jaden, what are these numbers in standard form?
2, 3 squared.
No, standard form, not exponential.
2
Okay, is that right? You all agree? 1, 2, 3, 4, yep. And then exponential form.
2, 3 squared.
Nope. Now, why won't it be to the third? How many 2's do I have there?
4.
4. So 2 to the 4th power times what, Jaden?
Times 5.
All right, nice. And box the whole entire thing. Any questions on this first one? When I was walking around, it looked like most of you guys got it. Don't forget your times 5 next to this one here, too.
I already did. Wait.
No, you did that in the exponential form, but make sure you do that in the, sorry, you did that in standard form. Make sure you do it in exponential form, too. All right, 2 factors of 63. What are 2 factors I can multiply together to get 63?
7 and 9.
7 and 9. All right, David, keep going. What do I do with my 7? What kind of number is 7?
7 is a composite number.
Not composite. Can I factor it?
Yeah.
You're stuck. That's okay. What kind of number is 7, you guys? How do we know it's prime? It only has 2 factors, 1 and 7 itself. Because it's prime, we're going to circle it. Now, can you factor 9? Yeah, what times what?
3 and 3.
Now, what kind of number is 3? So we're going to circle those as well. Standard form, Damon. How do I write these factors in standard form? And then exponential form? Perfect. Nice job. What's another way that you could say 3 to the 2nd power? It's another way that you could say 3 to the 2nd power.
3 squared.
Yeah, 3 squared. Do you guys all have the first 2 done correctly? Oh, where'd you mess up at? I thought you had it.
No, I had messed up.
It looked like you had it. Did you have your 9 first, then your 7?
No, I had a different number.
Okay, all right. All right, let's look at the next 2. 81. What times what equals 81? 9 times 9. Okay, quick question. If 81 was a square root, what would be the square root of 81? What is the square root of 81? What's the square root of 81?
9.
9. So 81 is a perfect square, right? If it was a square root. We know that because 9. All right, anyway, moving on. If I factor my 9s, what times what equals 9? 3, 3. 3, 3. What should I do with my 3s that I have here? Circle them. Good. Standard form. 3 times 3 times 3 times 3. Then what? Standard or exponential form. 3 to the 4th. Is that my final answer? Good. Okay. Now here's the fun one. I don't even know if I can write small enough to fit it all on there. So we have 1 million, and we need to factor 1 million. There's all different factors that I can use to multiply together to get 1 million. What are 2 factors that you use? You'll have time, I promise you. What are 2 numbers that I can multiply together to get 1 million? Not right now. Well, you don't want to use 1. You want to use 10. So if we use 10, that means we got rid of this. So how many zeros am I going to have my next factor? 5. So do we want to do that? Let's maybe do 100 and 1, 2, 3, 4. Let's do 110,000. Okay? After the opener. Okay, what 2 numbers can I multiply together to get 100? 10 and 10. Okay, what about for 10?
110.
What times what equals 10? 5 and 2. Prime numbers, I'm going to circle them. Okay, I go to my other 10. What 2 numbers can I multiply together to get 10? 2 and 5. Okay, so we're done with 100. Now we get to come to the 10,000. What 2 numbers can I multiply together to get 10,000? 10 and 1,000. Okay, so I'm going to use the 10. Now I'm going to be left with the 1,000. So 10 and 1,000. Okay? Can I factor 10? Yes. What are they? And we know that those are prime numbers, so I'm going to circle them. So now I come to the 1,000. What times what equals 1,000? Say it again. How about 110? So if we do 10, we'll have the 2 zeros left.
100 times 100 equals 10,000.
Okay, so what are my factors for 10 again? 2 and 5. What are my factors for 100? You cannot, I do not want you to use 10 and 10. What are 2 different factors for 100? You can, but just for the sake of mixing it up a little bit, what's 2 other factors I can multiply together to get 100? I don't want to use those though. I'm tired of using 10s. I want to use something else.
50 and 2.
What?
50 and 2.
50 and 2. What's some other ones?
5 and 25.
Not 5 and 25, but 5 and 20. If I use 25, what would I have to multiply?
You said to get 100, right?
Yeah.
5 and 25.
5 and 25 would not get me 100. It'd give me 125.
I'm not watching something. I'm going to watch on these.
2 times 50.
2 times 50 will get me 100.
Yeah, 2 times 50 will give you 100.
5, 25. You say 100.
125.
That mother's going to say
4 times what will get me to 100? Think about quarter. Yeah, 4 times 25. So let's do 2 and 50. If you guys did 10 and 10, that's fine. 2 is prime, so I'm going to circle it. What 2 numbers can I multiply together to get 50? You cannot use 5 and 10. I want something different. You can, in real life you can, but just me being stubborn, I don't want another 10. So what other 2 numbers can I multiply together to get 50?
25 times 2.
Okay. And we know that 2 is prime. All right. What 2 factors can I multiply together to get 25? Michael?
5 times.
And we are done because 5s are prime. So how many prime numbers do I end up having? 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. That's our longest one yet, isn't it?
No.
So how many 2s do I have? 1, 2, 3, 4, 5, 6. Okay, so I'm going to write out in standard form. 1, 2, 3, 4, 5, 6. And then how many 5s do I have?
6.
6.
2 to the 6 power of 5.
Hold on. 3, 4, 5. You're ahead of me. Okay. That's really long, right? Would you guys like me to do those type of problems all the time? No. Should your next worksheet be numbers that large? No. No? Yeah. It takes a lot of time, doesn't it? So if we have that in standard form, exponential form is going to look like what? 2 to the what? How many 2's do I have? Times 5 to the what? And then make sure you box the entire thing. Do we all have that? Because once I turn pages, I can't go back. It is gone. Why do you have... Good. No. Why do you have 2? Why do you have 6?
Oh.
There you go. I'm like, something didn't look right. All right, you guys ready for the square roots? If you are done with the front side, flip it over, look at the back side. Now remember, I'm extra picky in how I want you guys to show me your work. So make sure you just did not put the square root of 4 is a number. Make sure you showed me the appropriate work. If you don't know what the appropriate work looks like, I highly recommend getting your notes out from yesterday. Those notes will be helpful on your openers, your homework, and your quiz. We good? All right. Bless you. Okay. So when we're talking about square roots, basically it's a number that's being multiplied by itself to get that square root. So what's the square root of 4? What number can you multiply by itself to get to 4? 2. So do I just write my answer out as equals 2? No. How do I write it out? And then what else? And then what? Okay. Why am I crossing out the 2 in the square root? Yeah, square root and square are inverse operation. It means they cancel one another out. Like addition and subtraction are inverse, multiplication and division are inverse, square and square root are inverse. Okay? So what's the square root of 121? So how do I write it out? The square root of 11 squared cancels and becomes just 11. And then this last one, I know you have it on your worksheet. What's the square root of 0?
0.
So we're going to write it out. The square root of 0 squared cancels and equals 0.
But it's extra.
Why am I making you do extra now? Because I told you guys yesterday I was doing extra.
It is just 0.
Okay, give me a square root. And you don't have to write this in red. Give me a number.
10,000.
Do something other than 10. 21? No, let's do something other than 21.
24.
Let's do, we did 50 yesterday. Let's do 52. So you don't have to write this out in the red. So we're going to do the square root of 52. Type the square root of 52 into your calculator. So type the square root of 52 into your calculator. You don't know how. So you're going to hit second. Nope. You hit second. Square root button. 52. You're going to end up with a decimal, right? Well, that means that the square root of 52 is not a perfect square. So you're going to have to simplify it, which is what we're going to learn next week. Okay? So what you're going to do is factor 52. So you're going to do your factor tree. What 2 numbers can I multiply together to get 52? What 2 numbers can I multiply together to get 52? 13 and 4? Okay, so 4 and 13. Can I factor the 4? 2 and 2. Can I factor the 13? No, because it's a prime, so I'm going to circle it. So what I'm going to do, I'm going to come up to the right, put my square root sign. I'm going to put my 2 times 2 times 13. Now, what cancels with the square root sign? What's the inverse operation of square root? That little bitty what? Exponent 2, right? So square cancels with square root. What number does square refer to? Well, 2. So do I have 2 of anything up there? Yeah, I have 2 2's, right? So I'm going to circle those. That square and square root cancel, and that moves to my outside as my radical. My radicand then is the number that's stuck on the inside that doesn't have a pair to cancel out with that square root. That's why I'm making you write extra things now. I want you guys to understand that square, two numbers, cancel with the square root sign, and become one number on the outside. So I know it's extra, but do it.